In this video, we are going to understand how we can work with database. If you are following the series, then you would know that we have not implemented any database. We are not working with any database. Here we have this to-do service and here we have this list. As of now, we have used this list as our data source. But in real-time applications, usually we use one or the other database. It could be relational database, or these days we have no SQL database, any kind of database. We need something to store our data. Before we start working with database, let's have a quick overview of our web API. This is simple web API. Here we have only one controller. This is our to-do controller because this is to-do list web API. And few action methods. Get all, this will get all the to-do items. Then here we have this action method. Here we can pass ID and we can create new to-do item. And here we have update to do item action method, and here this method is for patch, and here we have this delete to do item action method. So, and we have created this abstraction, we have created this I to do service interface, and this to do service class implements this interface, and we are using this list as our data source. This is basic overview of our web API. In our web API, we are going to use SQL Server as database. SQL Server is a relational database management system which is developed by Microsoft. Please make sure you have the software installed in your system. In our application, we are having ASP.NET Core Web API, and we have decided to use SQL Server as database. But ASP.NET Core Web API is object-oriented programming application, whereas SQL Server is a relational database which understands structured query language. In order to make developers' life easier, we have something called as Entity Framework Core, which is ORM. ORM stands for Object Relational Mapper. This particular piece of software understands both object-oriented programming language as well as relational language, and it lets the developer work with relational database using object-oriented programming. ORM is a tool or a library that automatically maps database tables to objects. There are various ORM tools available in the market. Entity Framework Core is one such tool, and we are going to use that. And apart from Entity Framework Core, we have Hibernate, Django, SQLize, and many other tools. In summary, we are going to use this combination: ASP.NET Core Web API and Entity Framework Core as ORM tool, and SQL Server as our database. There are two main approaches to work with Entity Framework Core. First approach is code first approach. In this approach, we create our classes and other things first. Then using Entity Framework Core, we create database schema. And other approach is database first approach. In this approach, we first create database schema. Then using that schema, we create our classes and other things. In our application, we are going to choose code first approach. If you want to learn Entity Framework Core in detail, I have a playlist. I will mention the link in the description box. You can find all the related videos. When we are starting from scratch, we have to follow few steps when we have to work with Entity Framework Core. First step is to add Entity Framework Core to our project. As part of this, we add few NuGet packages like this Microsoft.Entity Framework Core, then this SQL Server package and this tools package. These packages, like, they help us to work with database seamlessly. We are going to install NuGet packages. You can go to Tools, NuGet Package Manager, then manage NuGet packages for solution. This will open window for us, and we can browse for the packages and we can add them to the solution. Or if you want to go for a console, you can choose Package Manager console. We have this Microsoft.Entity Framework Core. I will select this project and I will install. I accept. You can go to installed, and you can see the installed packages. As we are going to work with SQL Server, I'm going to install this package Microsoft.Entity Framework core.sql server. I will install this package. And I'm going to install this tools Microsoft.Entity Framework core.tools. See, I'll select this project. You can verify this. Here we have dependencies. Inside dependencies, we have packages. See, these are the packages that we have installed in this project. Our second step is to create the database context. This database context acts as a bridge between our application and the database. DbContext is going to be a class. Here I have created this data folder. I will add this new class. And I have named this as to-do context. Data context class plays very important role. We use this class to interact with the database. Now this is just a normal class. To make it DbContext, we need to inherit this class from DbContext. This DbContext class is going to have two important piece of information. One is constructor and second one is DbSet properties for each entity. See, here is the constructor. This constructor will take a parameter, that is DbContext options. Passing this parameter is very much important. We pass important information like connection string. So we need to have this parameterized constructor in DbContext class. Not only this, we need to pass these values that we have received in this constructor to the base class, that is DbContext. This is our base class, and we are going to pass these details to the base class constructor. Next important piece of information is to specify DbSet properties for each entity. These properties represent the tables in the database. Now, here I have added this DbSet property. So, to do items is of type DbSet. Here I have specified the class to do item. This is our to do item class. This has ID, title, and is complete. Table will be created for this to do item, and ID, title, and complete are going to be the columns. These are the two important information. Apart from these two, we can also override certain information. As we are going to work with relational database, we can specify which is going to be our primary key or the foreign key. We can even set up relationships. So there is an option to override one method, that is on model creating, and we can specify certain options. See, here I have pasted this code. This one. See, here I'm overriding this method. Which method? On model creating. This method is from DbContext. I'm overriding this method on model creating, and I'm specifying this primary key. Here in this entity, this ID is going to be the primary key. In Entity Framework core terms, we call this as configuring Fluent API. So this is one way to specify this kind of rules or relationships. One more way in Entity Framework core is to use data annotations. Here in this case, I have specified this ID as primary key using this Fluent API. Instead of using Fluent API, if you want to use data annotation attribute to specify the primary key, then we use this attribute key. This will tell the entity framework core that in this to-do item class, ID is going to be the primary key. We go for data annotations when we want simple configurations, but with Fluent API we can make complex configurations. The choice between using data annotation or Fluent API depends on the scenario that we are working with. In this example, we are going to use Fluent API, and I will remove this one. This is our DbContext class. Our next step is to configure the database connection. That means we are going to add the connection string. In our web API, we have a dedicated place to specify the settings, that is app settings file. We specify all the settings in this common place, and now we are going to specify connection string. If I want to specify connection string, I will add one more attribute, that is connection strings, and I'm going to specify connection string here. In connection string, we are going to specify server, then we are going to specify database name. This is our connection string. In app settings file, we store everything as key value base. Here connection strings is the key and this is a value. And in this value again here default connection is the key and this is the value. Here we have specified the server. This says like we are going to use local database and database name is to-do list DB. Trusted connection, if we specify this as true, then this will take Windows authentication as our basic mode of authentication. Please remember, we have not yet created this to-do list DB. As we have chosen code first approach, we are going to first create our model. Then using entity framework code commands, we are going to create this database. If you prefer database first approach, first you have to create this database schema in SQL Server. Then we are going to create models as per that. Next, we are going to register the DbContext as service. We do this because it can be injected wherever it is needed. Our next step is to register the context in dependency injection. We have already registered this to-do service with dependency injection container. Same way, we are going to register DbContext with dependency injection container. Builder.services. We are going to use this method, add context. If we use this add DbContext, this registers the given context as a service in iService collection. So I'm going to use this one and I will specify the class. Our DbContext is to-do context class. This is our class. Then now here we are going to pass some options. See, we are using SQL Server as our database. So we are using this use SQL Server and we are going to pass connection string. We have defined our connection string app settings file. Now we are going to retrieve that value. We have this get connection string method and we are going to specify the name of the connection string. Here we have given name as default connection. Here we have registered our DbContext as service and we have as we have the constructor, we have passed this options value which will use SQL Server as the database and we are passing the connection string. We are kind of done with all the setup. Now we start actually interacting with the database. For that, we inject to-do DbContext in the services or controllers wherever it is needed. This is our service, to-do service. Till now in our tutorial, we were using this hard-coded value. Now we are going to remove this hard-coded value and we are going to store our data in database and whenever needed, we are going to retrieve data from database. I will remove this list. This was our hard-coded value. Instead, I will declare this private field and I will add a constructor. So here we have this constructor and we are going to inject this to do DbContext. To avoid confusion, I will delete all this existing logic. Using this DbContext, we are going to perform all the CRUD operations. Now, this method is to add items to the database. We use this context, DbContext, and use this DbSetEntity. Which one? To do items. What we are going to do? We are going to add. What are we going to add? We are going to add this new item. Important thing to remember while working with Entity Framework core is just adding this item using this add method is not sufficient. There is one more important step, that is context.save changes. Writing this save changes method is very much important because this method is going to save the changes to the database. We are going to return this to do item. I have written logic for all other methods. In case of delete method, we are using this remove method. And same, don't forget to call this save changes method. Here, this way we can delete item from database. When we want to get all items, we don't have to do anything. Here, I'm just returning all items and I'm converting to list. Get by ID, here we are passing this ID and same for patch. In case of patch, here I'm doing this patch operation and I'm calling this save changes method. Here we have this update. I'm finding whether we have this item. If there is no item to update, we are returning null. Then we are updating the values and we are calling save changes method. This way we have written logic for CRUD operations. If you observe the code, what we are doing is synchronous operations. That means each task will wait for other tasks to complete. In case of database operations, this may hamper the performance. So when we work with databases, we go for asynchronous operations. Speciality of asynchronous operations is this allows tasks to run independently and this enables a program to perform other work while waiting for time-consuming tasks. Converting this code to asynchronous is very easy. For better readability and understandability, I will change the method name to add async. I will have to modify this method name here. Instead, here it will be add async. Here we are adding new item to this database context. Here I can say add. I can call this method add async. This will run asynchronously. And now we have to change the return type. Return type will be async task. This is going to be the return type, and while using this async operation we have to use this await keyword. Even here we have used save changes. We have one more version of save async, that is save async, and again here use await keyword. Now we have made this operation asynchronous, and here I'll copy this return type. I'll come to this interface and I'll change this declaration. I made all other methods asynchronous. Now we are going to call these asynchronous methods from our controller. See, get all async. Then here we have this. Earlier this was returning action result. Now we have to change the return type to async task, and while calling this asynchronous method we should use this await keyword. And let's modify rest of the code. I have modified other code. We are done with almost all the things, but one important step is pending. That is, we don't have a database yet. We have to execute few commands and we have to create our database as we have chosen code first approach. Our final step is to run database migrations. As part of this, first we are going to create migration. That means it will create a few files that will have the configuration for the database schema. And after that, we are going to update database schema based on the migration that we have created in our previous step. We can execute these commands using this package manager console. Here I will say add migration. This is the command. You can give some meaningful name. I will say create to do table and hit enter. Migration has been created successfully. Here this has created, I'll show you. Here see, it has created new folder migrations, and inside this folder, see, new files have been generated. This will create all the instructions to create the schema. Create table, name is going to be to do items, and these are going to be the columns and the types, and this is going to be the primary key, and if you delete, what will happen. So all kind of instructions will be stored here. Now we are going to execute one more command to update database schema. First time when we are doing it, then it will create database schema. If not, it will update database schema. We have to execute this command update database. After update database command, if everything goes well, you can see something like this. See here, executed command, this command create database. Then here you can see extra information. See, if everything is successful, you will get something like this. Then you can go to SQL Server and you can check if the database has been created. Update database command has created this database to do list DB, and it has created this table to do items. This is how we can create database table using code first approach. Now I'm going to query this table. Now I will execute this query. See, as of now we don't have any data. Now we are going to insert data using our API. Using this create to do item route, now we are going to insert data. I will insert something. Okay, this is my to do item. I will execute this. When I try to add new item or when I try to execute this get all, any method, I'm getting this error. That is internal server error, and this is related to some dependency injection. This is unable to resolve the service for this type. Let's see what could be the issue. Let's verify this program.cs file. Here we are registering this dependency. Here I'm adding this interface using add scope method. Here I'm telling my interface name, and this is my implementation class. This seems to be perfect. Let's come back to this to do controller and let's see the place where we are doing dependency injection. Here I am doing this dependency injection. I have this field I to do service, and inside the controller I'm injecting my dependency. Here if you notice, I have made a minor mistake. Here instead of specifying the interface, I have specified this implementation class. That's the reason I'm facing this issue. I will change it to I to do service. Now we are going to keep everything as it is and we are going to test it again. Again, I will try to create this new to do item. These are the values. When we try to insert new row, we got this error. This says cannot insert explicit value for identity column in the table when identity insert is set to off. The reason is, if you look at this to do item table, if you come to this database context, we have specified this ID as primary key. So we are not going to insert, we should not try to insert value into identity column unless we specify this thing explicitly. So now in my to do controller, I am trying to map this ID. So what I will do, I will remove this mapping because this identity column insertion will be taken care by the database. I will try to execute this again. I will execute this again. Here we have this add async method, and see, now I got this status code 201. That means item has been created successfully, and this is a value. See, ID has been updated. This is 1. So this way we have created new to do item, and I will try to execute this get all. Okay, using this get all route, I'm able to retrieve this to do item from database. Then we have one more get to do item by ID. I will say 1 and I will execute this. Okay, we are able to get this item. What if I give 2? So I got this 404, item not found. Even this is good. Then we have this update to do item. Let's try to update this ID 1, and I will say writing is complete to false. Then I will execute this. Fine. This record has been updated. Let's verify this using this get all endpoint. Execute. Here we have this item has been updated successfully. I will execute one more, that is delete to do item. I will pass this 1 as the value. Then I will try to delete this. Okay, response body, this has been deleted successfully. Let's verify this by executing this get all route. So item not found 404. So we have implemented CRUD operation successfully. If we have to quickly summarize, first we have added few NuGet packages to our project. Next, we have created the database context, and we have configured database connection in our app settings file, and we have registered database context at service in our program.cs file, and we modified our service class to interact with the database, and by running database migration commands, we have created our database. By following few simple steps, we can easily configure Entity Framework core and SQL Server database in our web API. That's all for today's session. I hope the session was useful. Thanks for your time. See you soon in the next video. Thank you.